Good day to whoever this may concern. We are Team Dressrosa and we have chosen the problem statement 2, which is personalized product recommendations. So these are the details of me and my team members. We are from Sardar Vallabhbhai National Institute of Technology, Surat. We'll start off with the deliverables and how we approached our problem statement, the use cases, the solutions we came up to it, the limitations we faced while building a solution, the future scope of what we think we can achieve, and finally a glossary of a few terms that we felt were pretty important. So we'll start off with the deliverables. The aim of a problem statement was to enhance user experience by implementing a personalized product ranking system. We went with the obvious route of choosing a machine learning model and we focused on the KNN algorithm to provide the two main features of content based filtering and collaborative based filtering. Our initial thoughts were that since it was a personalized recommendation system, we know how important it is. It's no longer an extra feature that you just add on, it's rather a must have for any e commerce company. According to the survey, 54% of retailers claimed that product recommendations function as the key driver of a higher average order value. So we knew how important the system was and how important a solution can be down in the line. So at the start, we came up with a few use cases or a very essential features that we believed a solution must have. So of course, it started off with a refined product exploration. Our solution should help users discover products they might be interested in based on their browsing history, purchase history, and preferences. This would lead to increased engagement, increase the one-on-one interaction. It would make the customers, the users, feel that the website is more friendly towards them. We also wanted to implement strategic cross-selling and upselling. Now, this would include commonly used marketing strategies, such as suggesting a phone case if the user is interested in a phone, or provide and hence cross-selling them, or upselling them the next best phone model when provided with a phone. Third was user profiling. We wanted to make use of the details that the users provide while creating the account. This would be used to analyze behavior, demographics, and preferences, and hence would offer more accurate recommendations tailored to each individual. And finally, we would like to provide a dynamic homepage. The homepage would be customized with product recommendations and hence are updated in real time based on the user's recent interactions and preferences. So once we had the use cases down, we started approaching and came up with solutions. The first was the homepage. When the user landed on the homepage for the very first time, we don't have much information about him or her. And hence our model would show the top 5 products from each category on the basis of the product ratings that were given by the other users. And this could be in the form of stars or a score. Next was we introduced similarity scores. That is, once a user has shown interest in a certain product, our model would display 3 products that share the highest similarity score. That is, these 3 products would be most similar to the one that the user is already interested in. Next, we made use of the information that the user provided, such as the age, gender, location, etc., that was for account creation, and hence provided them with products that are most suitable and hence given higher priority. And finally, of course, we included collaborative filtering. That is, we used cosine similarity in our KNN algorithm to divide our users into clusters of people having similar interests in similar products. While coming up with our solutions, we did face a few limitations, and they would be as follows. The KNN model's limitations included recommending a maximum of 3 products, solvable by increasing nearest numbers. The critical issue though was the cold start problem, affecting new users as rating driven recommendations disregarded user history. Unpopular items were overlooked, even though they would be the ones that the user is looking for, because the product would be too niche. Another limitation we faced was the content-based filtering algorithm was limited by the limited number of product features, potentially failing to accurately recommend when preferences surpass these constraints. The frequent changes that were provided in the features or the dynamic user preferences would render recommendations outdated or unable to adapt at times. A final limitation was that demographic features and recommendations may not encompass users' specific hobbies or lacked situational context. The general attributes like location, age, and gender fail to reflect the current needs and the emerging trends. Often, Privacy would also be a concern that may deter a few users from sharing their demographic data itself. Even though we had these limitations, we are still hopeful for the future of our solution. One of them would be the trending recommendations. This is, we would recommend products that align with the current trends, seasons, holidays, or events to capture user interest and boost sales. This could be in the form of recommending woolen clothes during the winter and thinner clothes during the summer. Or it could be as simple as us recommending sweets during the festival seasons. Next would be incorporating the user reviews and feedback into the recommendation system. Rather than just using the scores and the rating provided by the users, we could use sentimental analysis that would use words such as amazing and too good in order to boost products and give them higher priority, whereas negative words would give lesser priority to the products. And finally, of course, we would like a final fully developed website which would have a functioning front end, a back end, and have our model integrated into it. This would take into account user experience and comfort, so a user feels right at home. This would be the glossary. A few terms we just felt were important. Collaborative filtering, a technique that can filter out items that a user might like on the basis of reactions by similar users. Content-based filtering. It uses item features to recommend other items similar to what the user likes based on their previous actions or explicit feedback. And finally, the KNN algorithm. It uses proximity to make classifications or predictions about the grouping of an individual data point. Thank you. That would be it from my side. Now I would like my teammate Divya Avasti to go into the more inner workings of how our model exactly predicts.